The smallest planet in the solar system is also the most dangerous place you will never set foot on, and it shouldn't exist. Not like this. Not at all. Everything we know about how planets form says Mercury is an impossibility. A naked rock clinging to the sun, scarred by forces that should have destroyed it 100 times over. Yet here it is, waiting, silent, holding a secret so violent that when you finally hear it, you'll understand why we've never gone back. Let's start with the obvious. Mercury is close to the sun. Dangerously close. But that's not the problem. You already knew that. What you don't know is that being close to the sun isn't what makes Mercury violent. It's what the sun does to time. Imagine standing on Mercury's surface at noon. The temperature has just reached 800 degrees Fahrenheit, hot enough to melt lead. The sun hangs motionless in the sky, 3 times larger than you've ever seen it, and it stays there for days. Because one day on Mercury lasts 59 Earth days. But here's the contradiction. A year on Mercury is only 88 Earth days. That means on Mercury, you can celebrate 2 birthdays before you've experienced a single sunrise. But that's just the beginning. That's the polite introduction to a world that doesn't play by the rules. Because on Mercury, the sun doesn't rise in the east and set in the west. In some regions, it rises, stops, reverses direction, and sets in the same place it rose. The sky performs loops. The shadows grow, shrink, and grow again. If you were standing there, your own shadow would betray you, stretching and contracting in ways that make no sense. Because on Mercury, the physics of light bends to the will of a star that refuses to let go. Now stop. Think about what that means. A world where the sun moves backward across the sky isn't a world, it's a warning. And the warning is this: Mercury is not behaving like a planet. It's behaving like something that survived an extinction event. Which brings us to the first loop. Why does Mercury have a core that makes up 85% of its volume? Earth's core is about 15%. Mercury's core is so massive, so absurdly oversized, that it's like finding an apple with a pit the size of an orange. Planetary scientists looked at this and said, "That's not possible." And then they looked closer and realized something worse. The only way Mercury could have a core that large is if something stripped away its outer layers. All of them. Violently. This is where the theories get dark. The leading explanation is that Mercury was once a normal planet, 2 to 3 times its current size, orbiting in relative peace. And then something hit it. Not a glancing blow. A catastrophic, grazing impact that sheared off its crust, its mantle, almost its entire exterior, leaving behind nothing but a metallic core and a thin veneer of what used to be a world. But that's not the worst part. The worst part is that the impact didn't kill it. Mercury survived. It's still there, orbiting the sun with the scars of a collision that should have turned it into rubble. And the implications of that survival are what make this planet the most violent object in the inner solar system. Because if Mercury got stripped by a giant impact, then it's not a planet, it's a planetary corpse, a fossil of a world that died billions of years ago, still going through the motions, still pretending to be something it no longer is. But here's the problem. That giant impact theory? It has a hole. A massive one. Because if something hit Mercury hard enough to rip away its mantle, the debris should have fallen into the sun or scattered across the inner solar system. Instead, we see no evidence of that cataclysm in the asteroid belt. No isotopic signature in Earth's mantle. Nothing. So maybe the impact didn't happen. Maybe Mercury was born this way. And that's even worse. Because if Mercury formed with a core that size, it means the early solar system was a place of such extreme violence, such unimaginable temperatures, that the region closest to the sun became a refining furnace. Only metals could condense. Only iron could survive. Everything else was vaporized, blasted away by solar winds so intense they could strip an atmosphere in hours. That's the second loop, and it's still open. Was Mercury stripped by an impact, or was it forged in the mouth of a star? We don't know. But what we do know is that whichever answer is true, Mercury is telling us that the early solar system was not a gentle place. It was a war zone, and Mercury was on the front lines. Now let's take you to the surface. Because the violence isn't ancient history. It's happening right now. Mercury has no atmosphere, no blanket of gas to protect it. That means the sun doesn't just shine on Mercury, it attacks it. Every second, the solar wind, a stream of charged particles moving at 1,000,000 miles per hour, slams into the surface with no resistance. It doesn't erode the planet, it chemically transforms it. The surface is being sputtered, atom by atom, blasted into space. Mercury is literally evaporating. Slowly, yes. Over billions of years, the planet has lost a significant fraction of its mass just to this constant assault, and what's left is a world covered in a thin layer of rock that has been so thoroughly irradiated, so relentlessly battered, that it looks like nothing else in the solar system. But here's where it gets strange. Hidden beneath that irradiated crust, in the shadows of craters that never see sunlight, there's ice, water ice, on a planet hot enough to melt lead, on a world where daytime temperatures could incinerate organic material in seconds. The poles harbor deposits of frozen water, locked in eternal darkness, preserved by the same violence that makes the rest of the planet uninhabitable. That's a contradiction so sharp it cuts. A planet of fire and ice, existing in the same body, separated by nothing but shadow. And the ice shouldn't be there. Mercury is too close to the sun, too hot, too exposed. The only way ice survives is if it was delivered recently. Comets, asteroids, impacts that brought water to the inner solar system after Mercury had already cooled. Which means Mercury, the most violent planet, the one that should have been stripped clean, has been quietly collecting the seeds of life while the rest of the solar system was forming. But that's not the deepest secret. Not even close. The deepest secret is what Mercury is doing to our understanding of gravity. For decades, we've used Mercury as a proving ground for Einstein's theory of general relativity. The way its orbit shifts, the way it wobbles, the way it refuses to follow the predictions of Newtonian physics, it was the first evidence that space-time is curved. That gravity is not a force, but a distortion. Mercury, tiny Mercury, broke physics. And it still does, because when we sent the messenger probe to orbit Mercury, we discovered something no one expected. The planet has a magnetic field, an active global magnetic field, just like Earth. But Mercury's core is supposed to be too small, too cold, too dead to generate a magnetic field. By all rights, it should be inert, a frozen lump of iron. Instead, it's alive. Something is churning deep inside that core, something we don't understand, generating a magnetic field that deflects the solar wind and creates a tiny bubble of protection around a world that should have none. That magnetic field is a pulse, a heartbeat. Mercury is not dead. It's dormant, waiting. And here's the loop that closes and opens at the same time. If Mercury's core is still active, still generating a magnetic field after 4.5 billion years, then it has a heat source we don't understand. Something is keeping it warm. Something is keeping it alive. And that something could be the presence of elements we didn't expect. Or it could be tidal forces from the sun, squeezing the planet like a stress ball, generating friction, generating heat, keeping the core molten against all odds. But if the Sun is keeping Mercury's core alive through tidal forces, then Mercury isn't just a planet, it's a machine. A world being constantly needed, constantly stressed, constantly transformed by the star it orbits. And that means the violence isn't in its past. The violence is ongoing. Every orbit, every rotation, the Sun reaches out and wrings Mercury like a wet cloth, forcing it to generate a magnetic field, forcing it to stay active, forcing it to be something it was never meant to be. Let that sink in. Mercury is the closest planet to the Sun. That's the fact you came in with. But the reality is far more disturbing. Mercury is not simply close to the Sun. It is possessed by the Sun. Its day, its year, its surface, its core, its very existence is dictated by a star that refuses to let it rest. And now, the final piece. The one that turns this from a story about a planet into a story about our own future. Mercury is shrinking. As its core slowly cools, the planet contracts. The surface, unable to compress, buckles. Massive cliffs called lobate scarps cut across the landscape, some of them a mile high, hundreds of miles long. They are the wrinkles on a world that is getting smaller, tighter, denser with every passing million years. Eventually, Mercury will cool completely, the magnetic field will die, the core will solidify, and the Sun, billions of years from now, will expand. The red giant phase will swallow Mercury whole. The planet will be consumed, vaporized, returned to the star that shaped it. Mercury was born in fire. It will die in fire. And in between, it endured. But here's the unsettling thought, the one that lingers. We look at Mercury and see a world that shouldn't exist. A freak, an outlier. But what if we have it backwards? What if Mercury is not the exception? What if Mercury is the rule? What if most rocky planets in the universe are like Mercury? Stripped, irradiated, clinging to their stars, their surfaces blasted, their cores exposed. What if Earth is the anomaly? A world that happened to form far enough from its star to keep its atmosphere, its oceans, its life. A world that got lucky. When we look for exoplanets, we find them everywhere. And the most common type of planet in the galaxy is something we call a super-Earth, a rocky world larger than ours, often orbiting incredibly close to its star. Some of them are so close they orbit in hours, not days. Their surfaces are oceans of lava, their atmospheres are vaporized rock. They are Mercury's, but worse. So much worse. Which means the violence of Mercury is not a curiosity, it is the default state of planets in the universe. We exist because we are the exception. A quiet, stable world in a calm orbit, protected by a magnetic field, cushioned by an atmosphere, floating in the narrow band where water can be liquid and life can emerge. And somewhere out there, on a world just like Mercury, something might be looking at its parent star, wondering what it would be like to live on a planet that wasn't constantly being torn apart. But Mercury isn't looking. Mercury doesn't care. It's been here for 4.5 billion years, taking everything the Sun can throw at it. Impacts, radiation, tidal forces, extreme temperatures, and it's still here, still orbiting. Still hiding ice in its shadows, still generating a magnetic field that defies explanation. Mercury is the most violent planet in the solar system, not because it attacks, but because it survives. And when you look up at that small, unremarkable dot of light near the horizon, the one that appears just before sunrise or just after sunset, remember what you're seeing, a world that should have been destroyed. A world that refuses to die. A world that carries the scars of every impact, every betrayal, every impossible condition, and still keeps going. There's something deeply unsettling about that kind of persistence. Something that makes you wonder. If a dead rock clinging to a star can survive for billions of years against all odds, then maybe survival isn't about being strong. Maybe it's about being too stubborn to break. Mercury broke the laws of physics. It broke our models of planetary formation. It broke our assumptions about what a planet can endure. And it's not done breaking things. Because the longer we study Mercury, the more we realize we don't understand it. The magnetic field shouldn't exist. The ice shouldn't exist. The oversized core shouldn't exist. The shrinking surface shouldn't be so dramatic. Everything about Mercury is wrong. And yet there it is. A tiny, violent, impossible world, holding on by a thread, waiting for us to come back. To figure out its secrets. To understand how something so small, so close to destruction, could outlast almost everything else in the solar system. But here's the final question, the one that closes the last loop and opens a new one you didn't see coming. If Mercury can survive this long, this close to a star, in conditions that should annihilate anything, what else might be surviving out there? In the orbit of dead stars? In the atmospheres of gas giants? In the frozen voids between galaxies? We look for life in the quiet places, the safe places, the places like Earth. But maybe life, real life, persistent life, isn't found in the quiet. Maybe it's found in the violence. And maybe Mercury isn't a warning. Maybe it's a blueprint.